All right, we're going to go back a little bit, and we're just going to multiply these two expressions here. So, well, we're going to simplify them. I've got x plus 3 quantity squared and x minus 4 quantity squared. We're going to multiply these out, and what we'll do is just look into anything that we notice that we might be able to use in the future here. So let's multiply this out. So this will be x plus 3 times x plus 3. So I've got x times x is x squared, and then x times 3, that's plus 3x. Now I move to the 3, I go 3 times x, that's 3x, and then plus, and our last one is 3 times 3, which is 9. So what we end up with is x squared plus 6x plus 9. Okay, so we'll come back to that. Over here we've got x minus 4 times x minus 4, and we'll multiply this out. This is x times x, we get x squared, and then x times 4, and it's a minus because we're subtracting there, so this is minus 4x, and then we get minus 4x again, and then negative 4 times negative 4 is 16. And really, I probably should have written this as x plus negative 4 and then x plus negative 4 because it'd be easier to see where these come from. So we've got x squared minus 8x plus 16. Okay, so what do we notice here? What we have is we've got x squared plus 6x plus 9. And we started with x plus 3 quantity squared. And so the relationship between the numbers up here and what's down here is something that we have to figure out. We've got to come up with some kind of relationship there. And when you look at this, I've got a 3 here, I've got an x here, and we have 6x here. So that would be, if we looked at the relationship between the 3x and the 6x, if we multiplied this 3 times x, we would get 3x. And then if we multiply that by 2, we would get 6x. And this here, we've got, I can rewrite that, so we'll compare that. So it'd be x plus negative 4 quantity squared. Okay, so what do we notice? We started with x plus 3 quantity squared, and we got x squared plus 6x plus 9. There is a relationship between this, and this, and this. Now notice that we do have a coefficient of 1 up here, and we're going to find our relationship with a coefficient of 1 here, here, and here. So you'll notice that if we've got this 6 here, and if we cut that in half, we get that 3. We've got negative 8 here. We cut that in half, we get negative 4. So that's helpful. And I rewrote this x minus 4 quantity squared as an addition statement so that we can use the negative 4 there. So that's interesting. And then once we take half of this and get that 3, take half of this, and we get that negative 4, we could square it, and we get this 16. We square that, and we get this 9. And so let's write a way to kind of complete the square, and because that's what we're trying to do. We're doing this thing called completing the square, and so we'll find this relationship between this is a perfect square binomial, this is a perfect square trinomial, and we're squaring a binomial to get to that perfect square trinomial. And so our relationship is you have x squared plus bx plus, and then b, just like it's 6 here and it's negative 8 here, if I cut that b in half, so that would be b over 2, and then square it, I will get this number. So I cut this in half, I get 6 divided by 2 is 3, square it, I get 9. Negative 8 divided by 2 is negative 4. Square it, I get 16. And then that's equal to that binomial, x plus b over 2 quantity squared. So remember, b is right here, so that's this. And so we cut that in half, and we get 3. And so there's our x plus 3. So that would be x plus b over 2 quantity squared. So this is kind of the relationship we're going to go with here. And what we're going to be given in a second is a problem where you have x squared and bx, and you're going to try and find out what this is. So you're going to complete this, the square in the perfect square trinomial. So for example, x squared plus 20x plus c. What does this c have to be in order for us to make this a perfect square trinomial, which is, it comes from squaring a binomial. So what we'll do, we're going to take that b, which is 20, and we're going to cut it in half. Okay, so that's b over 2. And if you remember from the previous slide, we had x squared plus bx plus b over 2 squared. And this results in a perfect square trinomial. So if we take b, 20, cut it in half, and then square that, we'll get a perfect square trinomial. So 20 divided by 2 is 10. We'll square that, that's 100. So c has to be equal to 100 for it to be a perfect square trinomial. So that would be x squared plus 20x plus 100. This is a perfect square trinomial. Now if we want to write it as the equivalent squared binomial, we would have x plus, and then remember the binomial is equal to x plus b over 2 quantity squared. So b over 2 was 10, because remember it's b divided by 2, that's 20 divided by 2, that's 10 squared. So this here is the binomial squared, this is the perfect square trinomial, and these are equal to each other. So if I actually squared this, if I did x plus 10 times x plus 10, I would get this, x squared plus 20x plus 100. Let's do another. Okay, we've got x squared plus 12x plus c. In the book, they're actually not going to have c there, so I'll just erase that. But we're looking for what value does c have to be in order for it to be a perfect square trinomial. So again, we have this pattern, x squared plus bx plus b over 2 squared, and that'll equal x plus b over 2 squared. And it also could be like this, x squared minus bx plus b over 2 squared equals x minus b over 2 quantity squared. Okay, so we could have something like that. In this case, we have addition, so we're going to use this one. All right, so we're going to cut 12 in half, so that'll give us b over 2. So 12 divided by 2 is 6, and then we'll square that. So let me write that down. So we've got b over 2 is going to be 12 over 2, which is equal to 6. And then we need to square that. So we've got the b over 2, so that's 6. We need to square it to get that last term here, the c. So this would be b over 2 squared is equal to 6 squared, which is 36. So c is plus 36. So that'll create a perfect square trinomial. And then we want to write the binomial, so that would be x plus, and then b over 2. So remember that's right here. So this is we're working on this part, writing the binomial that we're going to square. So x plus b over 2, that would be x plus 12 over 2, which is 12 over 2, and then we'll square that. So that'd be x plus 6 quantity squared, and that equals x squared plus 12x plus 36. So this is the perfect square trinomial. This is the binomial squared that is equal to that perfect square trinomial. Okay, last one here. So we've got x squared minus 11x. We want to know, hey, what value of c is going to make this a perfect square trinomial? Okay, so we want to find out what c is. And then we also want to know x, in this case it's going to be minus because this is minus. So minus some number here, we'll just put a star here to hold that, and then time squared. So we want to first know what value of c makes this a perfect square trinomial. and then what is the binomial that we would square to get that perfect square trinomial. Okay, so we're going to cut, this is negative 11, we're going to cut that in half, so negative 11 over 2, and that we're just going to leave it as negative 11 halves. Whoops. Just like that. This is b over 2. So this equals b over 2. Okay, so now we know what b over 2 is. So we could actually, because we already know b over 2, let's just write our binomial. So this is x minus 11 over 2 squared. Done with that part. Now to get c, we just have to take negative 11 halves and just square it. So this would be negative 11 over 2 squared. That's 121 over 4. And so this is going to be x squared minus 11x plus 121 over 4. That is it. We are done. All right, so bring in questions, and hopefully this made some sense. And if you have questions, bring them in tomorrow, and we'll go over them.